You've championed the role of Assurative AI in engineering. So can you define this concept and then what makes it essential in sectors like civil engineering where safety and compliance are non-negotiable?
The idea really around Assurative AI in civil engineering is that we have to comply with a number of different things. You have, requirements from the employer, you have standards, you have project requirements, and these are non-negotiable to demonstrate safety. And even to get insurance, you have to be able to demonstrate this. So it's not enough to say, hey, chatbot, build me whatever. You need to demonstrate where information's come from, how it's been used. So Assurative really is this concept. It's a bit like...
Did you know that in safety-critical infrastructure, a single unchecked AI-generated error could jeopardize an entire system and public safety? That's why Assurative AI, technology that not only creates solutions but also verifies their compliance, is quickly becoming one of the most urgent developments in the AEC industry. In this episode of the AEC AI and Tech Strategy podcast, we'll be joined by Dr. Michael Rustell, CEO of Inframatic and Lecturer in Structural Engineering at Brunel University of London. He will share how AEC professionals can build AI that not only generates solutions, but proves they're safe and compliant. We'll also talk about the future of engineering productivity, the shift from static documents to structured data, and how to close the AI skills gap in AEC firms. If you're an engineer, tech leader, or innovator shaping the future of infrastructure, this is an episode you will not want to miss. Before we jump in, I wanted to tell you about our AEC PM Connect event, built for project managers who want to improve project delivery, communication, and leadership through practical sessions and tools. These events provide an avenue to connect with leading PMs in the industry. Visit aecpmconnect.com and register today. With that, let's jump into today's episode. Okay, it's now time for our conversation of the week with Dr. Michael Rustell. Michael, thank you for taking the time to join the show today. Welcome.
Thank you very much. Thank you for having me, and it's a pleasure to be talking to you again.
Absolutely, and I think you've got a very unique perspective that I'm excited to share with the audience here today. So let's jump into your background. So can you share a bit about the path that led you to your current roles as both a CEO and a lecturer in structural engineering?
I graduated during the recession, and recession was a hard time to get a job. So I was looking to actually go into industry, but the real path didn't lead me there because it was so difficult. After 100 odd job applications, I ended up looking at doctorates, and in the end, I applied to a few, got one of them, and it happened to be in something that was very specific to what I was doing previously in my master's dissertation. It was just a really good fit for me, so I ended up doing that. And it turns out that the doctorate I was doing was actually a industry doctorate. So I was working in a company doing it, which was great. That was in optimization of port terminal layouts, and that really set me up in the whole, AI in civil engineering sphere, because I was building software for 4 years, day in, day out, and I was doing it in maritime engineering, which I was, very passionate about. Towards the end of it, though, I wasn't really wanting to stay in the company because I was, it was a very research type role, and I wanted to be a detailed designer, which wasn't what the company did. So I went into industry, the sort of big industry. I worked for one of the big engineering firms, and I was just a ports engineer, and that was really good. But I had this additional skill set that was from building AI systems and from, basically being a researcher. So I had to learn how to be sort of an engineer because I'd been doing, software development, and it was quite like a baptism of fire, I would say, because I came in at a reasonably mid-level, but I was expected to have like 4 years of design experience, which I didn't have. I had 4 years of software development experience in the context of civil engineering. So I had to learn a lot. And that was really interesting because it was hard. And I kind of got very deep in tech. At the end of working at this big company, I was a maritime engineer doing oil and gas, doing nuclear, doing big ports. But also I made my way into the global leadership team for AI, which was cool because it was 100,000 people in the company. But it was very hard doing AI back then. Like AI was super difficult, like 7, 8, 9 years ago. Just nothing was repeatable in engineering. It was all very difficult to get data. Everything needed to be in tables back then as well. So I got frustrated. I tried to make that role really evolve into something more, but I don't think the industry or the company was ready. So, what did I do? I ended up left for academia, joined Brunel University as a lecturer in structural engineering, also set up my own company, Inframatic, which is kind of how we came into talking with one another. And, the company was set up really to provide the bridge between engineering and AI, which I saw didn't exist because it was very easy to get scopes of work wrong. Projects using AI just never left the pilot phase. They rarely actually made good pilots. It was just a train wreck, to be honest. And witnessing it in slow motion again and again was painful. So I kind of wanted to be that bridge. Academia gave me, a stable position and gave me the opportunity to go deep into research and deep into technical understanding. Company, I ended up doing a lot of work in the expert sector, in the expert witness sector, working on maritime disputes. Done quite a few of those now, and that's been very interesting. It's a bit of a mishmash of a path through, but kind of rolling forward to where we are now, the company really wasn't set up for that specifically. It was set up to build AI in engineering. And over the past, I'd say 3 years, the ideas that I had during my doctorate about the ability of a system that uses AI, that puts a human at the middle of that can help automate complex processes using standards, using vision understanding, using automation of complex workflows, wasn't possible a few years ago because, like I said, all the data had to be in tables. That's flipped now because LLMs have come in, and that was the secret ingredient. It was the ability to turn unstructured information into structure. That was part one. The second part now is agentic workflows, where we can build systems that have agency, that can automate, that can think, they can plan, they can, again, reason, but they can do some pretty amazing stuff. And kind of that set the platform for what I do now, which is really building a system to solve bigger industry problems of, efficiency, errors in design, and just dreaming what the industry could look like in the future and how to build that.
And so, Michael, you've got this cross between so software development, particularly artificial intelligence, and civil engineering, two at times can seem very different fields. So in the civil world, you've got a highly regulated industry with little to no room for error, right? Highly scrutinized. Software development, one of the things you hear, right? Break things quickly. So you've got, it's like two polar opposite schools of thought. Not to say that, you don't also have quality in software, right? So you've championed the role of assurative AI in engineering. So can you define this concept and then what makes it essential in sectors like civil engineering where safety and compliance are non-negotiable?
Yes, great question. So yes, I have straddled the two fairly separate fields that are more convergent now than they ever have been. But the idea really around assurative AI in civil engineering is that we have to comply with a number of different things. You have, requirements from the employer, you have standards, you have project requirements, and these are non-negotiable. To demonstrate safety and even to get insurance, you have to be able to demonstrate this. So it's not enough to say, hey, chatbot, build me whatever. You need to demonstrate where information's come from, how it's been used. So assurative really is this concept. It's a bit like guardrails that tell your AI what it can and can't say and give it like alignment and give it boundaries in which it can work. But what assurative does more than that is it finds the right rules are needed for the process that's being taken. For instance, if you're designing something, a beam, let's say, there's a set of equations that need to be used. There's input information that is required, and then there's checks on things like steel, yield strength, or whether you're doing concrete. You have these various things. So assurative really is the application of the right set of rules to justify and to guide your solution to something that's justifiably correct. So that's the whole thing about assurative. It's born in standards and employers' requirements, really.
In the AEC industry, skilled project managers are the backbone of success. EMI's AEC PM certification offers tailored training, ongoing support, and exclusive access to premium content that keeps your team sharp and effective. From foundational training to advanced leadership tools, set your team apart with certified growth. Learn more at aecpm.com. That's aecpm.com.
Which is really just born out of, right, the nature of the profession. So then how are you guys in Inframatic applying assurative AI in practice? And then what have you learned from some of the real world deployment within the AEC industry?
So what are we learning from it? It's difficult, I would say, is the first thing that you learn, because the rules are written by humans. So you have to understand standards as an engineer first and foremost. That's non-negotiable. you need to be able to then build systems that can extract and represent those rules in a way where they can be understood and used. And again, there's a huge learning curve there. You've also got copyright issues. So seeking the right permissions in order to use this kind of information is a massive one that I think people forget. And also there's the issue of liability, like who accepts liability over information. If you're saying this is how it's done and someone does it like that and it's not the way it should be done, there's this challenge there. So, trying to understand the legal and risk ramifications, I'd say is a big one. Now, in terms of like deployment of these systems, it goes in baby steps. So it starts off by just understanding how to apply the rules from one standard in an assurative manner. Once you can do that fairly well, you can then start looking at identifying the right standards from, the requirements, and then within that, finding the right parts. Once you can do that, you can then start looking at how different parts can be combined, because, for instance, you often refer from one standard to another, saying if you need to do plate design, then it's Eurocode 3 Part 5, and vice versa. So you have to be able to kind of create the knowledge map in a way that's reproducible and can be audited and can be understood by an AI and then can be used by an AI. So I guess there's lots of different bits to it, and you have to kind of get each one right, demonstrably so, before you can move to the next level.
And even I think just from personal experience using the technology, it's surprising how much better these systems are at understanding, let's call it, maybe not the right word, but unstructured human data, right? Like the mess of everything that we have, interpreting it as another person would, and then putting it in whatever format you so choose. Not to say that the problem's completely solved, but it just makes me think that the systems will only continue to get better at doing tasks such as those.
Yeah, I think there's two parts to that. One is just the modern agent architecture. That is getting amazingly powerful. If you're in software engineering at all, then you'll see that Claude Code is all the rage right now, and for good reason. It's unbelievable at how good it can automate things. Of course, for it to automate stuff, it needs to have the right information. So when it's building software, can just kind of go. If you wanted to build a bridge, let's say, then you'll design a bridge, then you need to have all that kind of information. Now, that's not saying that that's the kind of thing I want to do, automate the design of a bridge, but having information available to the system so it can plan, so it can make processes, so it can understand that kind of, that ethereal human way we write and turn those into rules. That's one thing. But two, can it do it reliably and consistently? So if I ask two different models, am I going to get two different answers? And that's really where the understanding and the structure of how you represent your domain knowledge and the standards themselves becomes really important, because you don't want to have tiny perturbations in your prompt to end up with wildly different outcomes. You need to try and tie that into kind of structured data that's been made from unstructured data and have guidelines that say how that can be used, and then ways of checking that it's the right information. So it's a large part of it's really dealing in this strange kind of qualitative space where we program with words now, we build with words, and the nuance of words is, my understanding, is different to yours potentially, and to Claude or Llama or Quen or whoever you're using.
Whereas so we'll, I guess, define it in two different ways. So deterministic system, like prior to LLMs, deterministic system, you run that same block of code every time, you're going to get the same output unless some sort of randomness was programmed intentionally. And then there's the qualitative piece of using words, and like the nuance and the context and our understanding being different is a really great way to put it, versus, like I say, like quantitative, right? For the engineers out there using spreadsheets, and again, getting the same exact output given the same inputs every time, which for a non-deterministic system like a large language model, right, you can give it the same prompt and you may get different answers. That's part of how these systems are built, correct?
Yeah, it is. Although there's one thing to add to that, is you can get your LLM to be deterministic with a temperature setting of 0. And that's really important. You want to have repeatability, but you also want to have flexibility for it to think through problems. I use the term think kind of, in air quotes. but for it to be able to approach problems in a new way. So ideally, you want something that has determinism in lots of areas, but then you want flexibility between, like, for decisions to be made and then to work out what needs to be done next. And ideally that to be executed as code, because code is checkable. You're more likely to get the right thing, but the ability for it to kind of try something, if it doesn't work, think about how to try it a different way. That's really important. But the things it might be trying might be bits of software you've already built, and working out what inputs to go to that. I think that's quite a nice happy medium, because you're then not losing the kind of creative, hallucination aspect of LLMs, which is kind of a gift, really. That's how they work. They hallucinate stuff. That's not a bug. That's a feature of what they are. But then the ability to tie that into deterministic workflows as much as possible, because then you have the auditability, which you need in order to justify anything that's going to have any real significance.
Really well said, especially the temperature setting, because I think for, when you're just a consumer using a consumer LLM, right, you don't necessarily have as much control over that or some of the other parameters that the model is using to run in the background. But it is interesting once you start thinking about it like that, because it's kind of like how we think, right? But we gain that way to check our own hallucination or connecting the dots between different ideas through our own experience. And these tools, I guess, have a different way of collecting what would be the equivalent of experience, right, based on their training data.
You've got a few aspects of that. One of which is the training data, which is what the model has readily available. And that's built into the matrices, like the weights, as we call them. But then separately to that, you can have databases which you can access, and it can then make queries to those databases, and then it can bring that information into its context. And then while it's in context, you can have a prompt of what you need to do, the information in which that output is likely to be, or that answer, and then the output style that you want. And that's the kind of, the classic 3-part prompt, what you want it to do, the context over which you want that, and then the output format. And each of those is really quite interesting, because the challenge we have, first of all, is like asking good questions that can then be interpreted into, database retrievals or web searches or whatever to find the right stuff. So you need to then have a good sort of agentic system that understands how to find things. You then bring that in, and then it's a case of what's the output of that need to do? Like, what are you trying to do? Is it a report? Is it calculation? Is it just some sort of assurance or checking of something? Again, these have formats and schemas which we use, and you need to be able to describe those and systemize those and version control them, and kind of build all of that into it so that you have something that is inventive but also can be tied into the rules which we need to demonstrate, and can give you things as an output which are just genuinely useful.
Now, and Michael, we've talked a little bit of theory behind how AI, particularly large language models, work, and then a little bit of the practicality of how you actually use them. So in AEC firms where technical AI expertise and then like really deep specific domain knowledge don't really exist in the same person or even the same firm, what are some practical ways that these firms can then bridge the AI skills gap, given everything that we've just spoken about and your experience in Inframatic?
Yeah, so it's an interesting one. I mean, that's the initial problem I set out to solve with the company, though I arguably have not solved it because we're talking about it right now, and we're a small company. But in terms of like practical things you can do, I mean, there's some really, really great courses out there, for one, just on prompting, but also prompting in AEC. There's one, I won't mention it specifically, but it's very well known by a person who's very sort of, vocal on LinkedIn about it. That's something which people can do to just get their hands on the ability of how to use tools, because you don't have to be building AI to be having useful AI, and to be doing stuff that makes makes impact. Up for the past few years, it's been about how can we learn AI, how can we learn to program it and stuff, and that's really, really useful, because if you can speak LLM language, you can get them to do some really, really cool stuff. In the next year or two, what we're seeing in software engineering is going to happen across many industries, and that is really the tools where you can just describe what you want, and swarms of agents go off and build these things for you. And they're getting so good at it, it's astounding, the skill at which they have of building things. And I think that what professionals will be doing in the next few years is not going to be, how do I use AI? AI is just going to be the interface you do things through. And you will say, I need to do this. And the system will build that thing to help you do that. Now, we are building systems that do that kind of thing, but we're not going to be the only one because, having widgets and apps that are built specific to the problem you need are checkable, and you can spin up for the exact problem you're trying to solve. That's a really, really interesting and very useful, thing. So, to wind back a little bit and to answer the question more directly, I think just learning how to speak LLM is a great thing, but just using the common tools that are out there without getting really smart about it. For those that want to go a bit deeper, learning how to build agentic systems that have structured output in various formats at various locations so you can get it to do the things you want, and learning how to combine multiple agents into a kind of composite system that does various things and then brings that all together. That's the kind of what I would set my students to do if they were wanted to do stuff like this. It's how do you bring all that together to get something at the end that's actually useful.
And I think that's a really nice high level description, because you're essentially telling anyone who's interested, you have to get good at, it's almost kind of like the human aspect of it, right? How do you communicate clearly to the system? How do you write good prompts, which is essentially the same thing you would do to, let's say, an intern, right? Giving them just very clear instructions about what you want them to do, which I think is great because, right, no technical background required, and it's something that everybody can work on almost immediately.
Yeah, definitely. I think the ability to communicate effectively, that's just a skill set that's becoming so important. One, for organizing, teams of agents really, but two, overseeing them. Where that gets interesting is that technical domain knowledge and the skill of being able to describe what it is you want, to list the information that's going to be needed for that because you understand what problem you're trying to solve, and then to help the AI to help you to do the problem. I think that's a really, really good thing. It doesn't negate you from having to understand the technical dimensions. You have to be very, very good technically to ask AI to do things that are really quite advanced. Otherwise, you're leaving its interpretation of the problem, which you don't know how much of that problem is in its training set, which could be none, really, because lots of engineering information is stored in companies, it's stored in standards and research, which is not available in the common training corpus. So one, you have to have a system that has access to that. Two, you have to be able to ask the right questions, and you have to be able to check the output of that for sense as well as for what's not there, which is the other really big thing. LLMs are great at outputting things, they're great at parsing things, great at summarizing, and it might be able to do it en masse and combine all of that. But it takes an expert to look at that and go, you missed something, or where's that thing, or there's a gap there. That's not an easy problem to solve. You can have things that look correct, look amazing, are huge solutions, but that's the problem itself, because validation of what's not there is the really, really hard thing.
Really well said, and I'll clarify. Technical as in, so you're going to need a domain expertise no matter what you're doing. Do you need to be as competent or skilled in the actual software engineering that goes into building these systems? It sounds like that's probably not the case for those of us that are just using it for our own domain-specific work. But I also really like how you stated that need for an expert. And I think it's that either cyborg or centaur approach where you're human and you're actively working with an AI system. The difference between a cyborg and a centaur being a centaur is there's a pretty clear dividing line between where the human stops and the computer begins, and a cyborg is more of a mix of the two. But either way, the need for human expertise doesn't go away.
No, and you have to have that. It's not a case of, try and get the human into the loop for the sake of it. It's the loop does not work without the human. You have to have human in this, because so much of what we've done as engineers relies on engineering judgment, and that comes down to you understanding things and experience and intuition. LLMs can approximate that, and they can do a pretty good job a lot of the time, but at the end of the day, you're not going to be able to find insurance for things that have been, that you can't sue an AI, at least not yet. So a human's always going to have to stand behind something, or a company, and the insurance aspect of that is complex. I mean, we're not at the step yet where I think, at least not as an industry, where we're having to find insurance for designs that, or things like full design automation systems, because that's going to be very, very complex as well. But yeah, I think that the human being able to guide the AI system, not necessarily to, you have to build everything from scratch, but if you know how to prompt it to build the things you need, and you have access to good data, then you're able to get what you need done if you can direct it correctly. So human is completely needed. And so just to kind of bring this monologue in, to bring in one more point, because I think it's relevant. I do think that the future of how we build things, maybe going 3 to 5 years in the future, but I do think that's not going to be huge companies. I think that you're going to find small companies of a handful of very, very talented people working together who are AI native, or that like the born digital consultancy, where you have just people who are very, very good engineers who really understand the problems, who have this army of well-curated, well-designed AI agents, and you're effectively getting them to do your bidding, but en masse. And I think you will literally find groups of 5-10 people working together to design things that would have taken 50 or 100 people before, and they'll do it in days, weeks, and you'll have unlimited number of retries and updates. Even if the project's half built, you'll still be able to recalibrate the design in the future. And those kind of people that understand that's a future which is possible to do, possibly even now, but certainly within a few years with where AI is now, and are preparing for that, are going to be in such an interesting position where the kind of power to create is just at your fingertips. Of course, we do need the systems that help you to do that, and that's the kind of system we're building. But we're not going to be the only one, and it's an idea that doesn't really exist except for in people's heads right now. So we're literally trying to build what that looks like. Obviously, there's very complex aspects around that because insurance, design liability. Is it correct? It's not going to be a things happening on day one. But 3 to 5 years' time, when those things have started to get ironed out a bit, and the trust in the systems is there, and the industry kind of catches on, and suddenly small companies are delivering projects for half the price in a tenth of the time. It's really going to upset the apple cart.
And there are examples of firms like that do exist today. So if you're interested and you're listening, just look up, first AI assisted design of a data center, just as an example, right? There are firms out there that are doing this, but what I will mention, just based on my own experience, right? There is a difference between marketing that says it can be done and then actually seeing it done. So, right, like any good engineer, remain skeptical and trust but verify, because personally, one of my biggest gripes is the marketing of this technology. And you get in particular non-technical people who, let's say, maybe speak to its abilities more than they should. And then when you go to put rubber to the road, it doesn't actually work as intended. So just make sure you're doing your own due diligence.
Yeah, definitely. There's a lot of solutions popping up, and I think that innovation managers are just being completely bombarded with tools that all sound very, very similar. Retrieval being a big thing in AI right now, the ability to find information, RAG, retrieval augmented generation, very, very useful technology, and, very accessible. Everyone wants to do it. It does scale okay, but where it scales really well is when you start to design your databases in a very robust way, and you start to create the retrieval systems that can interact with those. That's a completely different kettle of fish, but that's what you need to go from pilot demo over a few documents to entire corpuses of high quality information. So yeah, there's lots of similar sounding stuff out there for sure.
Yes, and the only way to really know is to try it for yourself. So, right, marketing's great, but again, just make sure you look at it for yourself. So, Michael, let's talk about some of these high-risk projects, particularly some that you have experience in, so like nuclear and offshore infrastructure. How do engineering teams adopt AI tools while ensuring full traceability and compliance with established standards? And then what approaches or tech can help ensure that these AI-generated or AI-assisted outputs remain transparent, audible, and aligned with regulatory requirements?
Well, I mean, that's Assurative AI in a nutshell. That's exactly what we want to do. You have information that's encoded in books, journals, standards. You have requirements from, well, you say the standards are part requirement, part process, but then you have employers' requirements, you have design bases, and all this kind of information. We're talking about the retrieval problem again. Being able to find the right information from that set and then bring that into the context of the problem you need. Well, that already gives you the audit trail, because you can trace the chunk of information. You can get confidence scores over reasoning capability. That's all doable now. So that gives you that traceability. Now, in terms of, I probably haven't defined some things here around like design. I don't think we're quite ready for full automated design yet. There are aspects of automation that are fully doable. Assurative's not necessarily that. It's about checking. It's about using the right stuff, but it's about providing the tools to the human to do that. But keep in mind that a lot of what we do as engineers isn't necessarily calculations. That's a fun part of the job. Thinking through problems is a fun part, but then a lot of what we do is like looking for that reference or trying to understand how to apply this or like where's that thing, or cross-referencing 5 or 6 drawings to make sure they're consistent, or fact-checking a report, or dealing with an RFI or an NCR of some sort. Like these are quite low-value tasks in terms of like they don't create anything usually, and they take up a lot of time. So those kind of things have a low risk profile, but they have a disproportionately large amount of time associated with their delivery. So, us, like many other companies, are focused on automating some of those lower hanging fruits because it's less risky and we spend most of our time there already. So, yeah.
And I appreciate that kind of outlay, but as we discussed earlier, and you know this really well, is the best checker using something like Assurative AI is a really experienced engineer who knows their domain well, and then is also familiar with or is AI native and can actually work on both sides of the coin, right? The deep domain expertise, and then being able to understand and keep up and recognize the value of these tools as they come out today. So again, no replacement for human experience, but if we can make everybody more efficient, it's a win-win.
Yeah, definitely. I think and I think the entry point to AI use is just dropping every day. So, you definitely need the domain expertise, no doubt about that. But you don't need as much AI knowledge as you did even a few months ago, and that's going to change in 6 months and 1 year. I think that ultimately where we'll get to is the system we build will be so easy to use. You'll just be able to use it and ask it to do things. It will just help you to do that. It won't have like a barrier to entry. You'll just say, I need to do this thing, whether it's, assure this design basis against the employer's requirements, or check that our subcontractor's design report follows the correct standards, or check that there's no errors in these drawings. You're just going to say, I need to do this thing, help me do it. It will then find the right bits of information, bring that to you, automate aspects of that, show you how that's done. And then you'll be able to just ask questions around that and say, what about this case? What about this? Or have I forgotten anything? Or can you check my emails to bring in that one from Nick who emailed me something that might be relevant to this, and just check if it is. And just the way of working is going to change to be a lot more fluid, and a combination of text, reports that you'll just be kind of chucking into the context, spoken word, maybe even drawings, and all these things together, just, and you'll be at the center of that. And obviously that might sound kind of complex, but it's not going to be hard for you to use. And as we start to build systems that are just adaptable to how people want to work, you'll find it's just so fluid, and you'll just be working in the way you want to work, doing stuff you enjoy doing, and AI will be helping you with that in all steps of the way. I mean, that's really where we're going with this, and part of what we're actually building.
And I think to add, being, let's say, an AI power user who's also got deep domain expertise in whatever you're doing is going to continue to become really valuable, and your market value as an individual is going to go up. And I think that happens to be the case because, like you said, the barrier to actually using these tools is dropping, but domain expertise and execution becomes more and more valuable. And part of my personal thesis on this is there's just not as much publicly available training data on the very specific and niche use cases that are out there for even civil engineering, right? It's just, you don't have every single large firm's database of everything publicly published to the internet. It just doesn't exist. So for the time being, that information that you've got up here as a domain expert in civil engineering is going to be and continue to be very valuable. So taking those two complementary skill sets, I think, is going to serve anyone well who is interested in going down that path.
Yeah, just on data. I mean, for some of the models which we're developing, the data doesn't exist in the public sphere, or maybe doesn't exist at all. So we have to either make that data, procure it, and that's expensive. It's time consuming. It's complex, and it requires a lot of checking. So we've had to do that kind of exercise to build things that do things that nothing else does. But also, as you mentioned, lots of companies have great data. But that great data is it's not necessarily every single report that's ever been built by them, or every drawing they've got, or every thing. You have to be selective over what's valuable and what's not. So there's this like big curation aspect of that as well. I don't think you're ever going to have companies just opening the doors and all of their data because that's their IP of how they design things. But and again, there is a lot of value in those data sets, but identifying what the value actually is, what's the pearls of real valuable stuff that no one else has that you can commercialize in some way to do something that's really, really useful and can kind of change your revenue potential. That's the key to it. It's not necessarily turn everything into searchable information. It's working out using your human intuition of what the problem is, what data you have that can be used to solve that, and then what AI you need to extract that knowledge out, apply it, and then create something that solves that.
And that could lead into another fun discussion on use of AI to just do whatever you do today in your business model more efficiently, or for some firms in some cases, use AI to build a completely different business model. Like you said, commercialization of whatever IP you have to spin into a startup or provide a different line of service. So there are multiple use cases. I just think it is a lot simpler to get started with. Let's use AI as an efficiency play and then see what else comes after.
Yeah, definitely. I mean, it's building compound AI systems, things that use multiple different models at different steps and have various things going on. They're very, very difficult to build. Building something simple is very, very simple. You can just ask ChatGPT, Claude, or any of them really to build you something that's fairly simple. They'll do a very good job of it. They fall apart a little bit when you start doing things that are more complex. However, I will say, the ability of these coding models in the past few months has just gone off the scale in terms of the complexity of tasks they can handle reliably. Power users of these systems because they've gone on the exponential curve now in terms of productivity, and that's an interesting one. So once you kind of go past the point of how good you are at using AI to do stuff, and that does require you to kind of go into the code a bit to do that. But once you get to that point, you suddenly end up on the other part of the exponential, and your ability to deliver high quality work the way you want it to, it's just crazy how productive you can actually be when you understand what you're doing.
And I read this somewhere, but that exponential curve, and I do think the term exponential gets misused a lot, especially if you're talking about, in many cases, it could be something that's just linear, but the rate of change is big and we think it's exponential. But this is actually exponential. And the way I've heard this described is you look at the progress of these systems to your left, and it kind of seems like they're, just slowly increasing. And then you look to your right and you look up and you're like, wow, that was a lot of change really quickly. And as people, we live in a linear world, right? We don't just speed up from 25 miles an hour 200 miles an hour in like an eighth of a second, right? So I think that rate of change and how good these systems get is a little foreign to us. And if you're not the power user in the seat looking at this stuff daily, it can be jarring.
Yeah, I'm feeling slightly jarred recently, and I've been using these systems for a while. I would say, the term exponential does apply very well in this type of situation because it's not just linear rates of change. Computers don't think linearly; they think in exponents. I say think in exponents, and kind of exponents not in brackets, but think. But computers, binary, and the base of numbers that can be represented as a exponential system. And we are linear thinkers. So when someone starts to be able to use AI systems, which, if you think about it, you can call an infinite number of agents. Really, it's only limited by compute availability, which that's only limited by your knowledge to get that ability and your cost you're willing to pay for it. So if you know what you're doing, you can literally have as many of these agents doing stuff for you, but you have to be able to coordinate that properly and tell them what they need to do and be able to, build the framework for them to do that. But as that gets easier and more established, there will be power users, companies that are power users that just arise out of nowhere seemingly and over very short timescales, start to have huge impacts in their domain. And I think the bigger players are going to sort of be caught with their pants down, to put it one way, that the ground will shift so quickly that by the time they realize, they'll already be so far behind, it's going to be very, very difficult to catch up. Now, without going too far into that, I think that's going to be a big thing that comes, really, just small agile companies that just start taking a bigger part of the pie because they can, and bigger ones who kind of sell bums on seats. That's the business model that is getting massively challenged right now. And those that can automate the application of knowledge are, they're going to forge entirely new ways of doing stuff.
And to that point, Michael, these bigger firms that have been doing business a certain way for a while, and if their leadership is, rightfully so, right? Let's just say like it's a big, publicly traded civil engineering company, right? There are pockets, I'm sure, that are actively looking at this type of stuff. But if, for example, they just decide, hey, this is the play we're going to execute because we have stakeholders to satisfy, and this is just the way we're going to operate, well, you don't have as much incentive internally to, I guess, disrupt yourself, let's say. But that small company who can come in, right, they don't have any of those same incentives to just do business as usual, which I think is good. It can also be bad, just depending on how you look at it. But that's, I think, something that you just need to come to terms with as an individual, is where you sit, where you work, what is the culture of your company, and how useful can your skill set be to that company, and really how much can you take advantage of these technologies?
Yeah. The big companies, they are all looking at this like very, very seriously, but it's very disruptive. They don't want to disrupt themselves. What will be beneficial to them in the sort of medium term is going to be the relationships you have with clients. And we're not going to disrupt relationships very, very quickly, or potentially at all. But where it becomes harder for that, that relationship to be the thing that holds, the pipeline of work for you, is when another company comes in and says, okay, we might not know you. We start to build a relationship with you as a client organization or whatever, but we then demonstrate that we can deliver that thing for you for half the price in, quarter the time. And the quality and cost point is so far different that it becomes irresponsible when you're particularly talking about, public spending, for you to go with like the very, very expensive solution, and over time you will find that some of these smaller companies that do that, they will do it so well. I mean, initially they won't. They'll make cock-ups and stuff, and that'll be bad press for everyone, and great for the sort of incumbents. But there are smaller companies that are coming for the incumbents right now, for sure, because the size of the prize is so large. And the incumbents, I think it genuinely is just a matter of time. And do they disrupt themselves? Do they try and change what they're doing? I don't know. It's a complex one, going from selling time to selling knowledge. It's not something you can just change very, very quickly. But a small company that's newly formed, I don't know, that's the kind of thing you can build into your DNA. So,
and you bring up a great point of the whole not disrupting relationships, because for some clients, for example, the trust they have with a firm or the individuals working at that firm can be a proxy for quality, right? So so cost and speed, those are things everybody gets. But if you're a client and you're not in like the domain of the work product that you're paying for, you don't always really know how to back check what you're getting. If you have somebody that can do that for you, that's great. But if you're using that relationship as a proxy, well, for somebody who's trying to unseat an incumbent, it's going to take time, because human-to-human relationships are still linear, unlike the progress of these exponential systems. So even though you can design something a tenth of the time, that's great. But if you can't actually get your buyer to buy that from you, that's still a problem that needs to be solved.
Yeah, and there's also another interesting aspect to that. I mean, that's completely correct what you said there. You might have the best thing, but trust is a huge, huge thing that doesn't take time. The other aspect of that is that, when it comes to liability, you can sue one of the big design firms. Are you going to be able to sue a startup or a tiny SME that is not worth that much? If it goes wrong, how do you recoup that? So that's another aspect, and that will keep the incumbents holding on for a long time. But I don't think that's something which will hold forever. I think that solutions to that will be built, and smaller consultancies that are well funded, that have the right insurance in place, that have the right expertise, and are just really well designed around having AI and data at the very core of what they do, and have the right team around that. They just will reshape it all, and it won't be too quick. It'll kind of construction. We all know that's a fairly slow moving industry, but when you bring the people into those companies that have the relationships, that understand the product, but also have worked in the industry for X years and kind of, have delivered projects, and they're then marrying that with the tech people who understand how to build stuff, that then is a very, very powerful, proxy. But of course, just onto one of your initial comments about that sort of like, the centaur or the cyborg, you have to have some of those in that for that glue to work. Otherwise, you've got people that know how to build construction projects, people that know how to build software. If you can't translate the two properly, not just a chatbot translation which looks correct but might have some errors in, but really understand how to organize that group of people around a common task, which is building or designing things using completely new frameworks, then again, it's going to be risky, but people are building these skills up. It's not just me anymore. This is where the industry's going. So
excellent. And any final piece of advice you'd like to share with AEC firm leaders that are aiming to adopt this technology responsibly while preserving professional standards, technical rigor, and everything else that comes with the profession of engineering?
I think the comment that pops into my mind there is just don't die, and that's that's a startup mentality. But AI is here. It's very, very useful, but jumping on the bandwagon too early doesn't necessarily, that's not necessarily the solution you need. It's not all doom and gloom. I do think that keeping an eye down for what's happening, particularly in software engineering, is worth doing, because that's where all the biggest breakthroughs are happening right now. And just being prepared to take some risks and to understand that the first projects you do, the first pilots, they may not solve everything you need to do. They may be complete flops, but getting used to this, fail fast mentality, and understanding that the size of the prize really is quite large. And if you are interested in having some of that, then you do need to move, and you do need to work out what you move with. So if you are an AEC senior professional, I'd say following what's going on in software engineering is probably going to be the biggest thing, and just seeing the velocity of how that's moving, or the kind of things that are happening there, will give you the ideas of what's coming into engineering and the things that you might be able to do yourself.
Excellent. And, Michael, thank you so much for taking the time to join the show today. The audience has questions for you or wants to expand on any of the topics we discussed today. What's the best way for them to connect with you?
You can get me through my email, which is mike@inframatic.com. Oh, sorry, .ai. So mike@inframatic.ai. Or just go on the website and you can, leave comments. It's www.inframatic.ai, and you can get in touch with me from there, or on LinkedIn. That's why I love talking to people on there.
Excellent. Michael, thank you again so much for taking the time to join the show today. I learned a lot, and I'm sure our audience also appreciates it.
Thank you. It's been a pleasure talking to you, Nick. And thanks everyone for listening.
Absolutely. Until next time. Please remember, you can find the show notes for this episode at aectechpodcast.com. There, you'll find a summary of the key points discussed in today's episode, as well as links to any of the resources, websites, or books mentioned during this episode. Until next time, I wish you the best in all your engineering and technology endeavors.